Any issues about a chord or a diameter is in a circle? We reviewed that day one. Any issues there before we start talking about different facts? All right, here we go with the first circle fact. What I'd like you to do first is right next to here at the bottom, wherever you have room, draw yourself a circle for me with a circle O for me. Circle O, the center of O. And we're going to draw in some radii and a diameter here in a second. Okay, so here's what I need. I need one radius, which we're going to call OB. Boom, OB. I need another radius, which is what we're going to call OD. And we need a diameter AOC. Here's what the first fact says. If you have two central angles that are congruent, so what I'm going to give you guys is that angle BOC and angle COD are congruent. So if angle BOC is congruent to angle COD, two central angles in a circle are congruent, that means their arcs are congruent. That's what this first theorem says. If you have two central angles in a circle, that means the arcs are congruent. So which two arcs up here would be congruent for us? BC congruent to arc CD. That's what that first theorem is saying. Okay, if the arcs are congruent, so central angles are congruent, so are the arcs. Okay, good. And the reverse is true. I could give you the arcs congruent instead. So if BC, arc BC, congruent to arc CD, if the arcs are congruent, then you could say, heck yeah, the central angles are congruent. BOC congruent to COD. All right, everybody good? Arcs are congruent, central angles, they go hand in hand. If one's congruent, so are the others. All right, there's the first theorem. Now let's turn our attention to the chords now. So draw another circle for me. You can just put a center point. We're not going to name it. We don't need to, but we're going to draw two chords in this diagram. One chord being CD, and the other chord being AB. Okay. Here's what the second theorem says. If the chords are congruent, so if I tell you these two chords up here, CD and AB are congruent, that must mean their arcs are congruent. Okay? So arc CD congruent to arc AB. Okay? So knowing those arcs are congruent are pretty powerful, because if the arcs are congruent, central angles are congruent, arcs are congruent, chords are congruent. Bella.
Could you say that part DBC and ACB?
DBC?
Yeah.
Say that. Okay, so DBC and which one?
ABD.
ABD.
Or,
Well, we know
yeah.
these are already congruent. So you could say ABD and CD. These are, yes, because this is, you can have a reflexive arc and add them, which we will be doing eventually in a proof. Yes. Okay. And reverse is true, everyone. Let's say I gave you the arcs were congruent. I started off by saying the arcs were congruent, CD and AB. Yes, you could tell me the chords are congruent. Questions? All right. Yes, Mike.
So since we're doing like all of these, I'm assuming we have to do proofs.
That is coming up tomorrow, yes. Yep, these will all be going in your reasons column, correct. Little change up now. No congruent arcs are given here. Here's what you're going to be given. And ADB. Name ADB. What is ADB in my circle? Diameter. And what's CE? And if I have a right angle there between them, that tells me they are perpendicular. So if you get a diameter and a chord that are perpendicular, ready to go, the chord gets bisected. All right. If I have a diameter and a chord that are perpendicular to each other, that chord is getting bisected. So anybody want to give me a little conclusion on this diagram? And what two pieces up here will be congruent to each other based on this theorem? Letty? EF and CF. Yep. All right. Good. Questions? Ready now. It is very rare that you will see a full diameter. Very rare that you're going to see a full diameter. Here's what I'm talking about. You may just see this as perpendicular to the chord. What's this right here? Radius. Is it still part of a diameter? Still works. You may see even less. Let me cover up that piece right there. Everyone see that little piece right there from the center to the intersection point? Is it still part of a diameter? Theorem still applies. All right, you will not, rarely will you see a full diameter. But if it's part of a diameter and it's perpendicular to a chord, boom, this thing still applies. Also, I didn't mention, because usually this is all that we're going to use it for, that it bisects the chord. It also bisects the arcs. All right, so also that arc CA is congruent to arc AE. Real good. Last one for today. Last one. Chords and how far they are away from the center of the circle. If you have two chords that are the same distance from the center, those chords have to be congruent. Okay? Two chords, same distance from the center, have to be congruent. So chord DE, congruent to CB. Everyone all right? There's not much I have to explain about that one, right? Two chords, same distance from the center, have to be congruent to each other. All right. I got a little task for you to see if you can help me out. This is also a review from this year. I got points D, E, and F on here. Points D, E, and F, and I need you to use your compass and straight edge to help me find a point that's equidistant from it. All right, and that point's going to be pretty powerful. So here's D, here's E, here's F. Obviously, the point's not going to be here. That's not going to be equidistant, right? Probably not going to be here. That's not going to be equidistant. Anybody? We have done this before. Do you remember being in the kitchen and I had a refrigerator, a stove, and maybe a microwave, and I wanted to put an island equidistant from the three? Anybody remember how I find where I should put that point that's equidistant from those three using my compass and a straight edge? And it's already at the top, so you can cheat too, but I'm going to do the perpendicular bisector for these two segments. And where they intersect will be the point that's equidistant. So I'm going to take my compass. So why the heck did I just randomly put in this question, find the point that's equidistant? What unit are we in? Circle unit, yeah. So this point's pretty powerful as far as a circle goes. If I said make a circle that goes through A, B, and C, this is what I would be doing. Anybody know what this point's going to be? That's the center point. Yeah. Why? Here's why. Here's why. If I draw that point to F, if I draw that point to E, if I draw that point to D, what are all the three of those segments called in the circle? Radii. And what do you know about all the radii in the same circle? They all have to be congruent. Absolutely. All right. So how do I make this circle now? I put my compass point on the center that you just found that's equidistant from D, E, and F. I open it up to one of the points. And there you go. It's going to go through D, E, and F. Look at that magic. So to find the center point, and I'll let you guys finish that up. Anybody, that's the center of a circle, yes, but anybody remember from unit 5 maybe? What I call that point? What we used to do is I used to make this into a triangle. So did I just draw the circle outside or inside that triangle? Outside. So I circumscribed it. It was called the circumcenter. Yep. Okay. So that's how you give me any 3 points, I can draw a circle through them. All right, without trying to guess where my compass has to go. All right, I'm setting you guys up for tomorrow now, because tomorrow we are starting proofs. I want to set you up. I'm going to give you basically givens, and I want you to tell me as much information as you can possible. I'll help you out with the reasons. First one, the 2 circles are congruent, and the 2 arcs are congruent. From there, and the 4 theorems we've talked about today, what else is true up here? So I got PR congruent to SU, and usually I mark the arcs congruent with hash marks, same as I did the segments. What else? Bella, go.
Chord PR is congruent to chord SU.
There you go. Chord PR has to be congruent to chord SU. All right, now I'm going to start helping you guys with what I expect in the reasons column when we start these circle proofs. Bella, how did you know? What information did I give you that led to this? So congruent arcs imply, or what led to, what, Bella? The congruent chords. So this is what I would start writing in my reasons column now. Oh, there's more. There's more, Mike.
The longer PR, the longer SU are.
That is true. That is true. I'm trying. What I'm trying to. You're absolutely correct, Mike. What I'm trying to do new circle facts. All right. I don't want to use anything old school yet. All right. I just want to harp on these new facts here. What else? Where there's more. Come on. There's more. Letty. I have no idea what you said. R. Okay, I'm going to keep building because there's more to that. There's more than that. Not only are these 2 and these 2, but if the circles are congruent, anybody remember from day 1? When are 2 circles congruent? If their radii are congruent. So just not these pairs, all 4 of them are congruent to each other. PQ, congruent to QR, congruent to ST, congruent to TU. How did I know? What was I given? What led me to that? What was I given? Congruent circles imply what? All radii are congruent. I'm looking for one more, though. And it's a fact we did today. If the arcs, remember the arcs were congruent, that means Bella gave me chords. Something else is congruent because of the arcs. Mike, the central angles, name them.
Angle PQR and ST.
Yep. Q and T are congruent because congruent arcs lead to congruent central angles. Okay, questions? Now, I know, could we go deeper, like Mike just used subtraction? Could I go deeper and say, hey, these are isosceles, so the angles across are congruent? I could go a little bit deeper, yes, but I just want to stick to the circle facts. All right, 2 minutes, you and your group right now. 2 minutes, right over here. Circles are congruent, chords are congruent. How many can you and your group come up with? And please just stick to circle facts. All right? We'll be putting on more reasons in there in the reasons column of your proof. All right, let me hear one thing that you and your group maybe discussed, or just you by yourself. 19. AB congruent to AC, congruent to JK, congruent to JL. Here you go. Congruent circles imply all radii are congruent. Yep. Got it. There's one thing. At least 2 more you can give me here. At least 2 more. How about 5? There you go. Arc BC congruent to arc KL. Because what was given to you? Yep. Congruent chords imply I have congruent arcs. All right. Now I have congruent arcs. That was not given, but you proved that true. Now that you have congruent arcs, we also have congruent, hey, 4. Yep. Yep. And before we go on to the algebra problems, just a quick note. You had to say the arcs were congruent before you said the central angles. There is no theorem that says because 2 chords are congruent, their central angles are congruent. There's no theorem. Yep. If you want, yep, that's fine. Yep. Anything else? Now use these facts to solve some algebraic problems. All right. And just so you guys know, when I say work reasons used, what I'm looking for is anytime we label a diagram based off a circle fact, I want to write the circle fact down. Look here, I'm looking for X. Looking for that little portion right there. It's not a radius, right? Right? It's not a radius, but it is part of a what if it's coming from the center? It's part of a diameter, and it's what to the chord? Perpendicular. If we need to go back, let's go back and look at that. What is happening if I have a diameter that's perpendicular to a chord? Bisects the chord. So anybody want to tell me what happens to that chord that's a length of 8? Turns into 2 pieces of 4. Yes. And let's not go ahead here because we just watch. Hey, aren't I using a circle fact to label 4 and 4 there? Let's write down the fact we just used. And this one's going to be a tough one to remember. We're just going to have to keep writing it down and writing it down. You had what here? A diameter. You could say diameter. That's fine. You don't need to say part of a diameter. We had a diameter that was what? Perpendicular to what? A chord. Does what? Bisects the chord. We'll be using this one a ton. All right, I just used the circle fact to put 4 and 4. Now can your algebraic, mathematical, geometrical skills take over and solve for X? Because that's not a circle fact. How can I solve for X now? 13, Pythag, yep. X squared plus 4 squared equals 5 squared. Yep. So X ends up being, what do you got for me, 16? Excuse me?
No, I'm doing it. I just didn't type it.
You need a
Wait, what?
you need your calculator for this? 5, well, first, 5 squared and 4 squared. I don't think you need a calc for that and moving things over. And it is a famous triple we've talked about. Pretty darn famous. Blank 4, 5. Just go ahead. If you got to use your calculator, that's fine. I'll just turn away. And
Oh, 3, 4, 5.
there we go. 3, 4, 5. Yep. All good, everybody. You all right, Zach?
Yeah.
Okay. And that 5 squared, that's usually 25, right?
No,
You were getting out your calculator. Don't say you knew that part.
no,
What part? Okay, what part were you going to use that device for? The subtraction of 25 and 16? That is a little tough, I know. Or the square root of 9? Which one we're going to use that for?
Well, you see, what I had here was x squared plus 16 equals 25.
Yep. I'm waiting to when the calculator is going to get used.
And then you see my number came up, and I was like, whoa.
So you just got rattled.
I got a little bit rattled.
Okay, gotcha. Yep. I caught you mid stride.
Yeah.
Yep. Okay. Good save. 4. Finding x. Ooh, there's really not much here, huh? What's labeled 6? Radius. Okay. What's the side that's not labeled? Another radius in the same circle. That means they're equal. So let's put a 6 here. And before we do any other algebraic work, I have not used this reason yet. How'd you know that was 6 again? Because it's a circle fact. Okay, I need a little bit more than all radii are congruent, because that's not a true statement, Mike. There we go. In the same circle, all radii are congruent. Does everyone see why it's necessary, must have, required to have in the same circle? Because if you leave that out and you just say all radii are congruent, I don't think so. All right, so that's 6. All right, how are you going to get x now? I want 2 different answers. How are you going to get 6? 2 different ways, excuse me. 14, how are we going to get x? You're darn right I can do Pythag. Anybody else? Actually, I won't call on anybody, but it's a right triangle, and it's isosceles. It's a 45, 45, 90, correct? Okay. You know I'm going that way. You Pythagoras, break down that radical. All right. Six. What's across from the 90? 6. Radical 2. I should have left it simplest radical form, but I did say round to the nearest 10th if necessary. So it is 6 radical 2, but it's also to the nearest 10th. That it does. 8.5. No units, so I don't put any units on my answer. All good. Next up, final one. Again, I want to write any circle fact I can here, finding both values of x. All right, what am I working with here? All right, I'm definitely working with part of a diameter here because it's coming from the center, and 2 chords that look to be 7 units away from the center. What do I know about those chords if they're both 7 units away from the center? They're congruent, all right? So here we go. Chords, what's the theorem? Chords, equidistant from the center are congruent. Okay, so if that chord's 6, this chord is 6. Using that theorem. Okay, how do I find each piece then? What theorem do I have to apply now? Because 6, we could go 5 and 1. We could go 3 and 3. We could go 4 and 2. Mike? Right? Isn't it part of a diameter perpendicular to a chord? We know it's getting bisected. Yep. So diameter. So I might start labeling here. 1, 2, diameter perpendicular to a chord bisects the chord. So x must equal 3. I just want you to know how these facts are used. I know most of you could have just raised your hand at the very beginning and said 3, but I want to see, write it down where it all comes from. Questions? Plenty of time. Let's get going. Plenty of time. And we are done.